2012, being hosted by CSIR IMTEC in the beautiful city of Chandigarh. The inaugural lecture of today, that is 22nd February 2012, is being done by Professor Samir K Brahmachari, who is the DG of CSIR and the Chief Mentor of OSDD. The prominent speakers of the day will be Dr. Bernard Munoz, Dr. Girish Sani, Dr. George Skizell, Dr. K Bhutani, Dr. Michael Galperin, and Dr. Jeff Barton.
Good morning, everybody. Welcome to OSCAT 2012. We are happy that a lot of people have applied for this conference. We got around 330 applications basically. Finally, 180 has been registered here. And you will be surprised to know that 35% who are contributing to the OSDD actively also got the support from the OSDD side foundation. So it's a quite good number, and people are coming from different places, and the speakers also, it's a quite reputed speakers here. So I will not take much time because our main person, mentor of the OSDD is here. So we'll give the maximum time to him. So first I will request our director, Dr.G.P.S to welcome the participants.
My dear friends, esteemed colleagues from abroad, Professor Brahmachari, many friends in the audience, students, guests from India, participants, it's a very special day for us because of a couple of reasons. One, IMTEC has been given the privilege of hosting you all and also getting an opportunity which we had got for the last several years of participating in a very adventurous, bold experiment which was launched by Dr. Brahmachari. I can tell you very frankly that it engendered a lot of skepticism in a lot of people when it was started. But today there are many converts, hundreds and thousands of converts, many students across the colleges in the country, many senior scientists also. Some of them grudgingly admit that this is going somewhere. And this is a great opportunity for IMTEC, I think, to participate in a very ennobling activity, because at the end of the day, this circumscribed, company-based, closed activity that has traditionally produced drugs at the frontiers of medicine is not giving the expectations. It's not delivering on the expectations. And this experiment, this no longer an experiment, actually a kind of an activity which will, I'm sure, turn into a tidal wave soon, is likely to produce new entities, molecules, old molecules rediscovered, so many new frontiers that it will be recognized as a major stream of drug discovery. So this is a great opportunity today. IMTEC has, CSR's leadership opened it up, the whole nation, many colleges, universities, national labs are looking at it with great enthusiasm. I hope that this meeting, next 3 days, will be very invigorating. It will give a chance to everybody to interact, get into new ideas, new collaborations. And IMTEC is very happy to host you all here. And Raghav's, a lot of credit goes to Ragav, who has organized it. His contributions in bioinformatics are very notable. And I think all of us will benefit from this interaction. Thank you very much. Welcome again and enjoy these 3-4 days. I will request Dr. Brahmachari to give his plenary address. Dr. Brahmachari.
Okay, thank you. Thank you, G.P.S Ragav, for organizing this meeting on the AJ's OSDD in this wonderful campus of CSIR, Institute of Microbial Technology. Thanks, Shani, for all your nice words. And my friends who have come all over the world to hear. And Dr. Bal Ganesh, who is our recent entrant to lead OSDD from the front. My colleagues of CSIR family, my OSDD team, students, young scientists, researchers. I realized that it is an extremely rare event that I have attended a conference outside my city where I was living and went out of Delhi or out of Bangalore, where my wife also participated in this conference. And I think I realized this may be the first time in India we have traveled together to attend the conference. And you know, in science, the most difficult part is to convince the unwilling referees and the editorial board members, the most difficult to pass your ideas through. And the second difficulty is the granting agencies, who doesn't permit first, then you can't write, even if you have a paper, you can't publish. Then you have to convince your students to do something that is never done before, because they'll come back and tell you there's no literature, how can we do this? That has never worked. Then of course, your own colleagues and peers, but I think you as a scientist will be more satisfied when you see that your wife is convinced and she is participating in the OSDD, then you realize that it's a very rare event for a husband to be able to get acknowledgement from the wife. So I want to thank my wife to be here with me for the first time in a conference where I am talking in India. I show this slide again to these young students, which is familiar to you, saying that innovation is nothing new. It's very innovative. India is a very innovative country, although we have just formed the National Innovation Council only a year back. But the fact remains, we are century-old innovation. Even in sex education, we have very innovative ways of teaching. Our Ayurveda, our personalized medicines were very innovative. So therefore, innovation is nothing special. Open source is nothing special, because the only literate Tagore, who is the Nobel laureate, said, where the mind is without fear and the head is held high, where the knowledge is free. And I came from that state. So to me, where the knowledge is free, and this was the belief even 500 years BC in the education system, and the knowledge was inscripted and people shared it. IMTEC is one of the CSIR laboratory among the 37 laboratories and biological sciences. Of course, we have one more CSIO, Instrumentation Laboratory of Chandigarh, and there are 37 laboratories and 39 outreach centers and several thousand people, and the budget is just about $1 billion reached. And that's the job I have, to make people do what they do, and I talk and take the credit. But the difficulty is, my major job is to get money. So when I visit a laboratory, the first thing I get worried that the director is going to ask for money. But I was very happy to see the money has been extremely well spent. The new building of the protein place is very, very nice to see. Before I talk open source, I wanted to show you a compare to CSIR, compared to Max Planck, CNRS, our Chinese Academy, the number of US patents that we hold, and this number continues to be very similar every year. So therefore, CSIR holds 90% of the US patent granted to public funded institutions in India, and all Indian Institute of Science, IIT, all put together is about 25 or 6%. So therefore, we speak from a position of strength when we talk about open source. And the cost of patent is about 1/7 to do it in CNRS and Max Planck, or about 1/12 with respect to the Chinese Academy of Sciences. So therefore, it is worth doing science here. But the problem is, conventional science of drug discovery is a distributed co-creation with huge confidentiality with a big law. And I'm sure Barnett Muno is here. Nobody knows better than him that this is the way we have been doing. And the conventional versus open source approach to drug discovery, what's our OSDD CSIR, is the lock is open. It is also distributed co-creation with research groups, industry collaboration, individuals participation, open data sharing, and everything is open. And this is the fundamental difference that we have created by creating a new approach to drug discovery. Why did we do? I was a genomic scientist. I had no idea about drug discovery. I always thought that I'm happy with the predictive markers and diagnostics. That's what I'll be happy with. But I realized that the cost of genome sequencing has fallen from billions of dollars to $1,000. Being an X-Prize Foundation member, I could realize advisory group that actually it is driving. And you might have seen recently, in 15 minutes now with a nanopore, you'll be able to do the whole human genome sequence. Then what is wrong that this drug discovery is going up and up and up? Either there is an accounting fudging, somebody is doing a fudging of accounting and making us fool, or actually very stupid people are doing wrong experiments all the time to spend a lot of money. So let's see how money gets spent. So if you look at the cost per launch capitalized based on the cycle time, cost per YPWP, you can see approximately $94 million goes here. Then the hit to lead level, $166 million. Lead optimization, $414 million. Then about preclinical, $150. So itself is $700 million. That's what is accounted for. This part is another $1 million. That's what is accounted for. But is it true? I don't know. If you do a simple arithmetic, then it is true. Maybe much higher. By taking the number of drugs that has come and number of drugs, the 15 years total expenditure of R&D, right? But I think Dr. Muno has a different statement, and I read somewhere recently that you have mentioned that there's a bad math happening somewhere, and $55 million is the right one. And I know, I have a report which I know that $22 to $25 million is the India cost for a new drug, completely beginning to end, if we make less and less mistake. So the whole idea is, how do we reduce our mistake and do this part cleverly so that whatever enters here actually passes through and not fall from large number to large number. That's not acceptable. And that's the whole idea, and I believe it is possible. Now, why I didn't believe it possible? Why we are failing? Because we haven't understood ourselves. We are one of the most eco-friendly bioreactor. We work on a very small energy. The information flows to idea oxygen, fertilizer that we secrete. Our energy consumption is 86 calories compared to a PC. It's an engineering marvel. And anything that goes wrong in this chemical reactor is the causes the disease. So therefore, understanding the disease process, we have to understand the whole human process, whole biology as a system. And I realized very soon, after publishing a paper in Journal of Theoretical Biology on modeling of schizophrenia bipolar disorder, identifying why DRD2 receptor works and why you need a calcium channel potential block, I realized I'll never be able to solve these problems because I could only simulate 16 or 20 or 80 or 100 pathway. Therefore, why not we do in a smaller organism? And that's the whole philosophy with which moving to tuberculosis. Those who are structural biologists, you should realize biology operates by these interactions. And all this interaction is the only one that happens. Nothing much happens beyond this. Actually, nobody knows that the protein doesn't know that this is an RNA, RNA doesn't know it's the DNA. It just binds the shape and charge complementary, and the shape and charge complementary actually causes all the interactions to happen. So therefore, the conventional process of protein folding, lead identification, lead optimization are the processes you go through, These are all structure specific, but simultaneous interacting of a small drug molecule with multiple protein targets is horrendous to do computation. So therefore, you can never expect that aspirin will bind this many ways. Then of course, you have many proteins which are folded into various forms, actually inside the cell active form, and those folded proteins can also bind, so the problem is much more complex. So going to 28,000 genes of human and 500,000 post-translational modification of splicing alternate proteins, one is not going to solve this in my lifetime. So I decided that better go back to a smaller organism and look into the problem much comprehensively. Now why you cannot solve this? So can we solve this by connecting the mind and machines together? And that's Science 2.0, and that's what OSDD is all about. If you recall, 3 years back, we assembled here. And team was very small. We were very excited that this many people could actually sit in this location and do things. And September 15th, we launched the 2008, and you remember, you did this annotation training school here, and these were the young people. All I can tell you, today the number of young people who are on these projects, it is not possible to make a slide with the photographs of all of them, and so it is very, very large.